So this is a limiting and excess reactant problem, also called limiting reagents. Reagent is just another word for reactant. And in this reaction, we're taking magnesium metal and we're combining it with and reacting it with hydrochloric acid. And in this process, we get hydrogen gas and we get magnesium chloride. Right? Because magnesium is going to replace the hydrogen, single replacement reaction. Magnesium is a +2, chlorine's a -2. And so now we need to balance it out. If we don't balance it out, we're going to have a hard time later on. So one magnesium on the left, one magnesium on the right. I see two hydrogens on the right side, so I better put two hydrogens there. Gives me two chlorines, and that should balance everything out. Okay, so now I have the reaction that I need. Okay, so in this reaction, it's telling me that I'm starting with 15.5 grams of the magnesium. And it also tells me that I'm starting with 18 grams of hydrochloric acid. It says, what is the largest mass of hydrogen gas that can be produced? So in both of these cases, I'm trying to figure out hydrogen gas. So really the magnesium chloride doesn't come into play in this reaction. So in both of these cases, I'm trying to predict how much hydrogen gas. Okay, so limiting reactant problems mean I just do two stoichiometry problems. So in this case, I have 15.5 grams is what I start with. And remember, I always use my units and my labels of magnesium. I'm going to draw my train tracks. Automatically drop down grams of magnesium here. Right? We're trying to make a prediction about hydrogen gas. So I do moles of magnesium up here. Okay. And automatically, I know I'm not trying to find moles of magnesium, I'm trying to find hydrogen gas. It says, what is the largest mass? I'm trying to find grams of hydrogen gas. So I have to do moles of magnesium. And hopefully you've seen with train tracks, it's just steps, right? You're just adding steps on. You do the same thing every time. Okay. And that's what stoichiometry means, is I can go from moles of magnesium into moles of hydrogen. That's the only step we've added to this from the beginning of the year, is this mole to mole ratio. And then I can go from moles of H2 into grams of H2. Okay. And so now filling this in, 1 mole of magnesium, right, off the periodic table, we know that is 1 mole is 24 grams. Okay. Where do I get my mole to mole ratios? I get an imaginary 1 in front of the hydrogen, 1 there. In front of the magnesium is a 1 as well. So it's just a 1-to-1 ratio there. So that makes life pretty easy for the calculations. And then 1 mole of hydrogen is 2 grams of hydrogen. So when I calculate that out, I take 15.5 grams times 2 divided by my 24. And it's telling me if all of my 15.5 grams of magnesium did react, and we're not saying it's going to, we're saying that's what we're trying to figure out. Does all of the magnesium react? If it did, I could potentially do 1.29 grams of hydrogen. Okay. And so now I need to figure out with my prediction from my hydrochloric acid. So I start with 18.0 grams of HCl. I do my grams of HCl down here, moles of HCl. Remember, I'm trying to predict how much hydrogen gas is formed. And so I go moles of HCl into grams of HCl. into moles of H2 again, just like we did in the last one. And then moles of H2 into grams of H2. Okay, so 1 mole of hydrochloric acid is 36.5 grams. And here, when I look at my equation, 1 mole of hydrogen gas is equal to 2 moles of hydrochloric acid. So 2 moles of hydrochloric acid, and then still 1 mole is 2 grams. So when I calculate this out, I end up getting 0.493 grams of hydrogen gas. So what we're asking here is, if I were to use all of this magnesium up, this is how much hydrogen I would produce. If I use all of this hydrochloric acid up, this is how much hydrogen I would produce. So this tells me that my hydrochloric acid is going to run out first. Because I produce a lower amount of hydrogen gas, it tells me that this hydrochloric acid is the limiting reactant. It is the reactant that runs out first because I can only make this amount of hydrogen. This number doesn't exist. I cross it out because I will never use that number for anything because it doesn't exist. The hydrochloric acid runs out before the magnesium, and I can only make 0.493 grams of hydrogen. Okay, so it says, what is the largest mass of hydrogen that can be produced right here? That is 0.493 grams is the largest mass that could be produced because the hydrochloric acid is the limiting reactant. That runs out first. I can only make 0.493 grams, which is excess, and by how much? Okay, so we know that if the hydrochloric acid is the limiting reactant, then my magnesium is the excess. So we need to figure out by how much is it excess. There's a couple of different ways to do this. I think the easiest way is to take my mass that I just used, and I'm going to do one more Stoich problem. Say 0.493 grams of hydrogen gas was produced. Okay. So I know that I started with 15.5 grams of magnesium, but I did not use all of my magnesium. And so we're trying to figure out how much is left over. Well, I know how much hydrogen was produced, but I don't know exactly how much magnesium we used. So that's just another Stoich problem. I can go from grams of hydrogen into moles of hydrogen, and then moles of hydrogen into moles of magnesium, and then moles of magnesium into grams of magnesium. And I already have these numbers above, so it makes it pretty quick. 1 mole is 2 grams. It is a 1-to-1 ratio from the top that we saw. And then 1 mole of magnesium is 24 grams. So when I do that calculation, I end up with 5.92 grams of magnesium. Okay? So we're saying if I start with 15.5 grams of magnesium, I don't use it all to make the 0.493 grams of hydrogen. I only use 5.92 grams of it. And so how much is left over? We just take our 15.5 grams minus our 5.92 grams, and we get 9.6 grams of magnesium left over. So that's how much of my magnesium is left over. Okay, so these problems are long and they're tedious. Once you get the hang of them, though, they're actually not that bad because the process is the same. So The math is not too bad, so it's long, but conceptually is where you need to figure out what we're talking about. Okay? And so try to work through the next problem on your own using this one as a model, and I will post another video for the next one.